Hey kids, we're going to look today at integrals where there are position, velocity, and acceleration involved. So I'm going to remind you of when we were doing derivatives, how that works. So they usually call S of t the position formula. Sometimes you'll see it as x of t, but basically it's S of t is your position. That's the original function. If I take the derivative of S of t, remember that that puts me at velocity, right? And again, that shouldn't be anything new to you either. How about if I go the second derivative of position? Second derivative of position is the first derivative of velocity, which is acceleration, A of t. But here's what's going to happen in this section. They're going to give you, say for example, the acceleration and ask you to find the original function. So that means you have to take 2 steps backwards. In other words, you have to integrate. If you integrate acceleration, you're going to get velocity. And if you integrate velocity, you're going to get position. And so it's kind of like going backwards to get the function. I think we did things like this back in the last unit when we were looking at particular solutions for differential equations and such. So it's similar to that. It's just a more word problem-y text that you're given for these. So let's try one. A particle moves along the x-axis with an acceleration of 12t minus 4. The particle's velocity is 18 centimeters per second when t is 2. The initial position of the particle is 8. What is the function? They're calling it x of t rather than s of t, but same thing. That represents the position of the particle. We want to find the position. Well, the only thing they gave me was acceleration, so we're going to start with that. The acceleration they said was 12t minus 4. All right, if I take the integral of that, that's going to give me velocity. Velocity is going to be the integral of 12t minus 4. All right, so we're going to integrate that. The integral of 12t is going to be 12t squared over 2. The integral of 4 is 4t plus c. Can I make that prettier? And the answer is yes. I can have 6t squared minus 4t plus c. Well, they gave us enough information. In order for me to take a step back again, they need to give me some information about what c would be. And they said the second sentence here, the particle's velocity is 18 centimeters per second when t is 2. So in other words, 18 is the velocity when t equals 2. Looks like this. This is a 2 plus c. That enables me to solve for c. And so I've got 24 minus 8, and then I move that over to the other side. I get a c of 2. So my real final velocity formula is 6t squared minus 4t plus 2. But I'm not done, because now they want me to go backwards again to get the position formula. So now to get the position formula, I'm going to take the integral of velocity. So x of t equals the integral of velocity, 6t squared minus 4t plus 2. By the way, if you don't put that notation of dt at the end, Mr. AP is very unhappy and takes points off. So make sure that you put that in there. All right, let's take that antiderivative to get x of t. Well, x of t would be 6t cubed over 3 minus 4t squared over 2 plus 2t plus c. I'm going to make that prettier. I'm going to come over here because I'm going to need some room for finding c. So x of t equals 2t cubed minus 2t squared plus 2t plus c. Lots of 2 t's in that. But they told me that the next sentence, the initial position, well, that just means when t is 0, right? You're initially starting when t is 0. The particle is 8 centimeters. So I know that x of t is 8. All of my t's become 0, 0, 0, 0 plus c. So my c is 8. And that gives me a final answer that I can say the position formula is 2t cubed minus 2t squared plus 2t plus 8. And that's your final and best answer for that one. Okay, second one. Hold on just a second. I know the doggy's going to be barking. I just closed the window he normally barks out of, so maybe he won't interrupt us this time. Okay, Mr. Bruce is driving across town to Mr. Sullivan's house to play with a new set of Star Wars figures. Mr. Bruce's speed would obviously vary throughout the drive, but because he's so cool, he came up with a function that represents his velocity in miles per minute at any time t minutes since he left his house during the 30-minute drive. Set up the expression for the following scenarios and then use your calculator to solve. So here's the expression. Well, he wasn't very nice to us, was he? He gave us trig functions and logarithms all in the same shebang. And we say, thank you very much. All right, so step one. How far is Mr. Bruce from his house after 10 minutes? All right. By the way, as I'm looking at this graph, when I'm below the x-axis with these guys in this real-world situation, it means I'm going the wrong way. He starts out going the wrong way. And then above the x-axis is moving towards his house, which is the right way. So he goes the wrong way, the right way, the wrong way, the right way, and then he's good to go. Maybe he hit a detour. I don't know. Anyway, how far is Mr. Bruce from his house after 10 minutes? That's a distance. Remember how integrals work with distances. It's going to be the integral going from 0 to 10 minutes, of my function v of t, the velocity function. Now, you have options with this on the AP exam. You can put this entire function, and sometimes we do that. We'll put the entire function in here. But since they're saying use a calculator to solve it, since they named it v of t, I'm going to call it v of t. So I don't have to write all that out. That's a waste of my time. So I'm going to go to the calculator, and I'm going to, now in the calculator, you got to literally put the thing in. So you're going to do the integral going from 0 to 10 of this function. And the calculator gives you out an answer that is 3.01. This is a distance. How far is he? And the distance is in miles. So after 10 minutes, he's 3 miles away from his house. After 15 minutes, how far is he from his house? Part B. Well, how does that change things? Not by much. Now I'm 0 to 15 of v of t. Hopefully he's a little bit further at this point, and he is. By the way, if you forget how to evaluate these integrals on the calculator, I'll see you in class, and you can ask me and I'll show you. I think we've done it a few different ways. I've shown you on the home menu how to do it and through graphs how to do it. So if you're stuck on that, I'll show you how to get these numbers. Just holla when we get to class. All right, so I get 3.397 miles. If I go to C, if Mr. Bruce arrives at Mr. Sullivan's house after 30 minutes, how far away does he live? How far again? It's another distance thing. In 30 minutes, took him 30 minutes to get there. What is my distance for this? And so if I put it again in my calculator, 22.824, which by the way, once you put it in for the first thing, the rest of these should be pretty easy because it's already a function that's in your y1 or however you did it. So this is miles. He's 22.824 miles away. How many miles did he actually drive though? He drove, now think about it, he drove more miles than this because sometimes he went the wrong way. So how many miles did he drive? In order to get that, here's what you need to do. You're going to go, it took him 30 minutes to get there, but you want to know how far this is that was the wrong way and how far this little piece is that was the wrong way that you can add then to your integral. Because remember, these integrals are net values. It takes whatever's above the x-axis and subtracts away whatever's below the x-axis. So this is the net, and you're looking for the total numbers of miles that he drove. So what you need to do is pull these guys up above the axis to the positive part. You're going to take the absolute value of v of t. Now, if you remember in your calculator, it's either in the catalog, ABS. Normally, I just alpha it in because it's just as quick. If I use the alpha button and type in ABS, that gives me the same thing. So I can get the absolute value in there. All right, again, go to your calculator and you get an answer of 28.497. and that again is miles. So you can see it's a little bit more, kind of makes sense, because you know sometimes he was going the wrong way. So if I'm integrating velocity, that's considered to be the displacement. And that is, as I just was explaining, it takes whatever's above the x-axis and subtracts away whatever's below the x-axis. So it's your net displacement. If you take the absolute value, though, that gives you your total distance. And that's the difference between C and D there. And that's not to be confused with, when we were studying derivatives, the absolute value of velocity is speed, which does not come up in this section, but just as a reminder, if you're thinking, oh, I remember seeing that before, you did. It's the absolute value of velocity is speed. All right, we have a couple more example problems, and then I'll do a few practice problems, and we'll call it section A2. Here we go, number 3. Number 3 says, a particle's velocity is given by this formula. The function x of t represents the position of the particle along the x-axis. Find the position of the particle after 3 seconds if x of 0 is 5. All right, here's a little different scenario. They told you where you're starting off, right? And if they tell you where you're starting, an initial position for this thing, x of 0 is an initial position, you need to start with where it starts. It starts at 5. It's not starting at 0. It's starting at 5. And so you're going to take 5 plus, now comes the integral of where it's going after 3 seconds. So it starts at 5 at 0, and you want to know what it's doing when it gets to 3, 0 to 3. All right, so again, I can use the v of t function. We're going to do this one by hand, so I'll put the function in here. We're not going to use a calculator on this guy. 4t cubed minus 6t squared plus 1. All right, so 5 plus, if I integrate this, this will be 4t to the 4th over 4. Well, that's t to the 4th. This will be 6t cubed over 3 minus 2t squared, cubed, plus 1t. All right, going from 0 to 3. 5 plus. Put the 3 in. 3 to the 4th is actually 81. 3 cubed is 27 times 2 is 54. And plus a 3. If I put a 0 in, 0, 0, 0, everybody 0. Okay. So I have 5 plus all that hot mess comes out to be 30. And I get 35. Do I have units? And I do not. Okay, that's it. So if they give you a position of where it's at, you've got to use that in your equation when you go to find this. So the second one, find the position of the particle after 2 seconds. If at 1, it's at negative 2. Well, if it's at negative 2, first 2 seconds, I know where it is at 1. From 0 to 1, the answer is negative 2. From 0 to 1, I get a negative 2. I'm going to add on what it's doing then from 1 to 2, because I want to know what it's doing for the first 2 seconds. Here's what it's doing for the first second, 0 to 1. Here's what it's doing for the second from 1 to 2. Same exact equation, so I've got the same thing going on. 4t cubed minus 6t squared plus 1. When I integrate, I get t to the 4th minus 2t cubed plus t, but this time it's going between 1 and 2. So negative 2 plus. If I plug a 2 in there, I get 16. I get 2 cubed is 8 times 2 is minus 16, and I get plus 2. So that's a 2. We'll come back to that in a second. Minus. If I put a 1 in here, I get 1 minus 2 plus 1. And so I end up with negative 2 in the front. This is going to be plus 16 minus 16 is 0 plus 2. And this is a 2 minus 2, so that's 0. And so I get an answer that's 0. All that worked for a whole lot of nothing. All right, next one. Number 4 says, what is the total distance? Total distance, absolute value, traveled by a particle during the first 4 seconds if the particle's velocity function is given by this. Show the setup and your work. They gave us a picture this time too, which is kind of cool. They gave us a picture, and I want to know what it's doing over the first 4 seconds. Now, there's a couple different ways that you can do this. And some of it goes back to things you learned previously. So I'm looking for this area and this area. I'm doing different colors because one's above the x-axis and one's below the x-axis. If I want total distance, then I want to take whatever this is and add it with the absolute value of this. So geometrically, we did this back in the day. I took the area of this triangle. Let's see what the area would be. I'm going to do it 2 different ways. First way is we'll do it geometrically, a way that you learned already. So I would know that the total distance would be the area of these triangles. So the area of the first triangle equals, that would be this guy, 1/2, a base of 2, and a height of 3. That equals 3. If I go to area of triangle 2, that's this guy. If I take him, he is 1/2 the height of, the base of 2, and a height of 3 again, right? But technically it's negative because it's below the x-axis. Well, remember we're looking for total distance, so it's going to be the absolute value of that -3, which is 3, and 3 plus 3 gives me an answer of 6. Geometrically, that's an option that we learned previously. But this time they want us to look at it more algebraically, more calculus-minded. And so what I'm going to do, the first thing I need to do is know where it switches, where it goes from above the x-axis to below the x-axis. It looks like it's 2, but I can verify that because that would be where the velocity equals 0. So I'm going to first verify that this really is 2, where I'm going to split this thing up. So 0 equals -1.5t plus 3. If I solve that for t, 3 comes to the other side, and you can see that that very much does come out to be a 2. And what that means is what you have to do is then take this thing and split it into 2 separate integrals, because you need to take the absolute value of the one that goes below the x-axis. And so you can see from the graph that you're going to have the integral going, first of all, from 0 to 2 of -1.5t plus 3. And then the second one is going to be the one that you need to take the absolute value of. So it's going to be going from 2 to 4 for the same function, -1.5t plus 3, but you need to take the absolute value of that because it's below. Now, if you didn't know which one was below the x-axis, just absolute value both of them. It doesn't really matter. Or wait until you get to the end and know that you've got to take the absolute value of them. All right, so here we go. If I do 0 to 2, first of all, I've got to find the antiderivative. Antiderivative would be, this is like, let me go to the margin here. This would be like -3/2 t. So if I were to take the derivative of that, it's the integral of that, -3/2 t squared over 2. Right, take half of it. So really this first term is going to be a -3/4 t squared. A little trickier because of the fraction there, plus 3t. I want to evaluate that from 0 to 2, and then I'm going to do the same thing over here. I'm going to take that same exact integral, and I'm going to evaluate that going from 2 to 4. So let's see if we can do this quick. If I plug a 2 in here, I will have 2 squared is 4. The 4's cancel. I get a -3. I will have a 6. If I put a 0 in, it's a 0. So there's my first bracket there. Second one, if I put a 4 in, 4 squared is 16. 16 cancels with the 4, but it stays 4, so -3 times 4 is a -12. If I put a 4 in here, I get plus 12. Interesting. If I put a 2 in, well, we just saw what the 2 was. The 2 is going to be a value of -3 plus 6, so that's a value of 3. And so here I go. I have 3 for this guy. I have 3 for this guy. Actually, this was a plus, right? I'm adding them. Plus, I get a 3 for this. Actually, this was a minus. This, I got my signs backwards there. This is the minus. But it's the absolute value of that value. It's the absolute value of this guy right here. And so 3 plus 3 gives me that value of 6 again, and you just did it with the calculus way. All right, so algebra way, geometry way and calculus way, they both should match. And that's all the examples for this stuff. So let's see if we can pick a couple of practice problems to look at. The first one that I wanted to do is number 4. Number 4. A lot of these are the same as the example problems. So you'll just follow along with what those examples were. Number 4, though, is a little bit different, I think. So number 4, yeah, this one had a funkiness to it that I wanted to look at. A particle moves along the y-axis with an acceleration of 12t minus 6, with an initial velocity of negative 10 and initial position of 0. Find the position of the function at the particle's minimum velocity. I thought this might mess you up right there when they're asking you for the minimum velocity. Well, if you think about minimums, minimum, the minimum velocity happens when v prime of t, or whatever it is, equals 0. Now think about that for a minute. If I have a regular old polynomial from back in the day and I ask you to find the minimum, I give you the original function and I ask you to find a minimum, you're going to go to the first derivative, set it equal to 0, and yada yada, do your thing. This time it's asking you when the velocity has a minimum. So I've got to go to its derivative and do its thing. So that's why I'm taking the derivative of velocity, because I'm asked where the minimum velocity is. So I've got to go to the next derivative after it to get there. Well, they tell you what the derivative of velocity is. It's acceleration. So that means that I can just take the acceleration, set it equal to 0, and that'll give me my minimum velocity, which is what I'm going to need for the problem. So here I go, 0 equals 12t minus 6. Swing the 6 over, I get t is 1/2. Now I'm going to put that on hold because that's going to come into play in just a minute. Okay, so here I go. First thing I've got is I'm trying to go back to the position formula from the acceleration. So I'm going to take velocity first. There's no way to go from acceleration directly to position, so I got to go through velocity to get there. Velocity is going to be the integral of 12t minus 6. All right, so if I do the integral, 12t squared over 2 minus 6t plus c. They gave me information. Initial velocity is -10. Well, if that's the case, the initial velocity, this means when t is 0. If t equals 0, 0, 0, then my initial velocity is -10. So that means that c would be -10. They're just giving it to me in a funny way. All right, so c equals -10. Here is my official velocity formula. 12 divided by 2, t squared minus 6t minus 10. All right, then they're going to give me, I'm not there yet, I'm at velocity, that's cool, but I need to get to position. I'm going to call my position s of t. As the integral then of 6t squared minus 6t minus 10 dt. Take the integral, s of t. I'll have 6t cubed over 3. I'll have minus 6t squared over 2 minus 10t, technically plus c. But look at this one. This time it says, in my words, that the initial position is 0. Well, that means so that when t equals 0, my function equals 0. 0 here and a 0 for all these t's means that c is 0. So for this one, I know c equals 0 because everybody zeroes out. So let's see what the official formula is for s of t. S of t would equal 2t cubed minus 3t squared minus 10t. And did I answer the question? Find the position of the function at the particle's minimum value. I didn't finish yet because now I got to put in a t of 1/2. Whatever that is, then that's going to be my final best answer. So they didn't ask me for what the position formula is. They asked me to evaluate it at the minimum velocity. So I'm finding s of 1/2. It's going to look like this. 2 times 1/2 cubed minus 3 times 1/2 squared minus 10 times 1/2. Let's see if we can calculate this out. I have, if I cube this, I get 1/8. 1/8 times 2 is 1/4. I'll put s of 1/2. If I square this, 1/4. 1/4 times 3 is 3/4. And half of 10 is 5. So when I put that all together, I get an answer that is -5 1/2. And that's what my position would be at the particle's minimum velocity. So don't let those things mess you up. You know what that is. Just think it through a little bit from your previous knowledge. All right, next one I want to do is number 9. Number 9. This kind of summarizes the entire section a bit because it's taking you from what the value of the function is at its position, what the net change of distance is, and what the total distance is. So it's kind of a summary of a lot of the things that we talked about. So particle's velocity is given by this function where t is measured in minutes, v is measured in meters per minute, and s of t represents the particle's position. S of 1 is -3. What's the value of s of 3? This is one where they start with an initial thing. You know that the particle at 1 is at -3, so you've got to start with that. So I'm looking at this thing, and I have, it's going to be a -3 plus. And then where am I trying to take it? In the part, what is the value of s of 3? I know what it's doing at 1. From 0 to 1, it's at -3. But I don't know what it's doing from 1 to 3, and that's what I need to put on my integral. And so when I do that, I have the integral of t squared plus 2t minus 15. And then I just calculate that out. That's going to be my value. So the deal is you got to remember that if they give you a position for it to start with, that's what you're going to use, and then you create the integral from there. All right, equals -3 plus the integral of t squared is t cubed over 3 plus 2t squared over 2 minus 15t. So you come up with, and that's going between 1 and 3. So if I clean that up so I can plug it in, it's going to be t cubed over 3, right? The 2's cancel out here, so it's going to be plus t squared. And then I have minus 15t. So there's my cleaned up integral that I can f of b minus f of a, putting in a 3. By the way, there's a plus sign in here. Going between 3 and 1. So let's see if we can get that. Because they didn't tell us it was a calculator active question, we were supposed to do it the long way. Plug a 3 in. T cubed. 3 cubed is 27. 27 divided by 3 is 9. 3 squared is 9. 9 plus 9. 3 times 15 is 45, so minus 45. If I put a 1 in, I get a 1/3. I get a 1 plus 1. and I get a minus 15. All right, one more round, and then we'll see if we can simplify. Negative 3 plus 18 minus 45 is negative 27. And I have 1/3 minus 14. So I've got to go through and I've got to get common denominators, yada, yada, yada. I'm not going to waste your time on a video to do that because I trust you can. So negative 49/3 is what you should come up with. This one, they did give you units, it's meters, and so there you go. That is the value of S of 3. Second one is net change. All right, so net change means just the flat out derivative, integral. And remember, integral is like displacement, it's like your net change. So we're taking the integral. What's the integral, net change, over the first 5 minutes? So I'm going to set up my integral 0 to 5. And I've got the same function. It is t squared plus 2t minus 15. It has the same antiderivative of t cubed over 3 plus t squared minus 15t. Do you love hearing the puppy in the background? Oh, the life of the Winter household. All right, there's my situation. All right, if I put a 5 in, putting a 5 in gives me 125, 5 cubed, 125. Woo! 125 over 3. If I put a 5 in here, plus 25. If I put a 5 in here, it's minus 75. That's the beginning of this. But then if I put a 0 in, 0, 0, 0, I get 0 out. And again, you're going to calculate that out, common denominators and such, and your answer for this part is negative 25/3 meters. All right, then the last part says, what's the total distance traveled by this thing? And you notice this time they did not give you a graph of anything that you could use your geometric knowledge on, because in that last example that we did with the geometry way was way easier than figuring it out the calculus way, right? So we don't have that option this time. We've got to go with the calculus route. So I need to know where it crosses the x-axis so I know how to split the integral. So if I do that, I'm going to take t squared, my function, plus 2t minus 15, set it equal to 0, and factor it. I get t plus 5 and t minus 3. This is back to basic old algebra factoring. Gives me t equals negative 5 and t equals a positive 3. So you say to yourself, t is in minutes. Can I have negative 5 minutes? And you say, no, can't have that. So this guy gets canceled out because you can't have time that's negative. So your only time is this one here where t equals 3. So I'm going to take my integrals. The first one is going from 0 to 3. And I'm going to put this as v of t dt. And I'm going to add it with the integral of going from 3 to 5. I want to know what it's doing for the first 5 minutes. And when I get these answers, I'm going to take the absolute value of them. So I might put the absolute values on the outside this time. When I get the answer for each of those, I'm going to absolute value them so I can add them together to get the total distance that's traveled with this thing. I already know the antiderivatives, so let me set them up. It's going to be t cubed over 3 plus t squared minus 15t going from 0 to 3. And then the second one's going to be going same exact antiderivative going from 3 to 5. All right, so let's see if we can do this. And again, it's going to be absolute value of those. So you can keep putting those absolute value signs, or just remember at the end you got to do that. So plugging in a 3. Well, didn't we do that up here somewhere? We probably did. We did up here. This was plugging a 3 in. So I get 9 plus 9 minus 45. That gave me a negative 27. So I know that this first part, when I plug it in, if you can use your previous knowledge, go for it. I've got a negative 27 when I plug a 3 in. When I plug a 0 in, I get 0. All right, absolute value gives me 27. Plus, when I plug a 5 in, I guess I'm looking to see if we ever figured that out. We did not, so I guess we got to figure out this guy. If I put a 5 in, I've got that 125 thirds plus 25 minus 75. Now I'm going to kind of keep going with that part of it. Oh, also minus, that's just the beginning of it. It's this guy. Minus when I put a 3 in, and we know the 3 gives me negative 27. Absolute value of that result. So let me see if I can calculate this a little better. So I'm going to just come up here, 125 thirds, and 25 minus 75 is a negative 50. That would be 125 thirds, and if I multiply this guy by 3, it's 150 thirds. Gives me a negative 25 thirds that I then need to add 27 with. 27. So that would be negative 25 thirds. Can you see me? Yeah, you can see me. Negative 25 thirds plus 27 thirds. 27 times 3, I want to say, is 81 thirds. That's going to give me, if I add them together, 56 thirds. Okay, so that's what all this is. And so it's going to be plus 27 plus 56 thirds. And so again, I'm going to add them up. This was 81 thirds plus 56 thirds, and I get 45 and 2/3 meters. Whew. All right, so that question is a typical AP exam type question where it asks you all sorts of different things, but based off the same function and scenario. One last one that I want to look at, and that is number 12. Here goes 12. Hang on, let me show you it. Number 12. The graph to the right shows the velocity of an object moving along the x-axis over a 5-second period. Find the total distance traveled by the object over the 5-second period. Did they give you an equation this time? And they did not. And so this goes back to stuff that you learned previously with geometry. If I want to know the total distance, I take anything that's below the area between the curve and the x-axis, and I take the absolute value of the pieces that are below and add it with the pieces above. So that's what I'm going to do with this one. I have to divide it up into shapes. So really what I want to know is, if I were to look at this, see this area here? That's the positive area. He's fine the way he is. But all of these guys below, I need to know what these areas are, which is where I'm going to have to divide it into different shapes to be able to figure that out. And what I'm going to do is take the absolute value of the guys below and add it with the one above. So I'm looking for, technically, this is my calculus, 0 to 5. I want to know what the absolute value of V of t dt is. Right? That's going to give me total distance. So I choose. I'm going to choose a trapezoid to here. Let's do that first. So my area of a trapezoid, and this trapezoid is kind of funky because it's sideways. So you almost need to look at it this way. That I have, my bases are 3 and 1, and the height is 2. Okay? So you have the parallel sides are your bases, 1 and 3, and the height is 2. So that's what I'm going to use in my formula. So it is going to be 1/2 the height of 2 and the sum of the bases, 1 plus 3. Okay, so this is the first area I've got going on. And it is below the x-axis, but I want the absolute value of it, so I'm just going to keep it as a positive. I need to add that with, I'm going to go with a square for this section, a 1 by 1 square. There you go, 1 times 1 is 1. And then I'm going to go with this little triangle. And my little triangle that's there, 1/2 the base. Well, the base is only a half. Now I'm estimating, right? I have no real idea, but it looks like it's about a half. And then the height is 1. And then I have the last triangle here. It is also a triangle that's pretty. My red triangle, 1/2, a base of 2, and a height of 3. And so I set up my 3 or 4 actually scenarios there, and I'm just taking the absolute value of them, so I left them as all positive values. All right, half of 2 cancels out. I have 4 for this guy, plus 1, plus 1/2 times 1/2 is 1/4, and then I have the 2's cancel, so I've got a plus 3, and so I end up with 4, 5, 8 1/4. I pause because 25, it's not the same thing I got when I did this earlier. So let me see if I can figure out what I did or didn't do. 12. Total distance. I don't see a problem with it, so I'm going to leave it at 8 1/4. All right, here we go. Last one. This is it, I promise. At time t equals 2, we can talk about this in class. See if you have a differing opinion on that. I can tell you that the answer the book got was 15/2. Okay, so we can look at that. They actually put this as negatives. They took all these negatives and then absolute valued it later. So I don't know. I don't understand why that wouldn't be why this wouldn't work. So I think I'm good with the 8 1/4. But they said 15/2. We can have a class discussion on that. Last one. At time t equals 2, the particle is at a point where x is 10. Where is the particle at time t equals 0? Well, you know what it's doing at 2, right? So you know that at 2, you've got it going to 10. What you don't know is what it's doing from at time t equals 2, the particle is at the point 10. Where was the particle at t equals 0? So you're going backwards this time. It's kind of weird. So instead of you plussing this, you know where it is at 2. You're going to take away the integral going from 0 to 2. You want to go backwards. You want to go left and figure out where it was at 0. That's why it's a minus instead of a plus, which we normally see. All right, so let's see. If I do that, I have 10, and then I have minus. Now they want to know, what am I going, 0 to 2? Well, 0 to 2 is this first trapezoid that I did. It has a value of 4, but remember, this one isn't asking about total distance anymore. So this one is literally, since it's below the x-axis, you're using the -4 value that it is. So up here you would do an absolute values. Down here they're not asking for that at all. They're saying, you know, where was it? So here I go. It was at 14. And we don't have units for that, so that's my final best answer. All right, I will see you in class. Shoot me questions if you have any, and keep going. We're almost done. You can do this.